So it's time to move over for our op 2. And I'm going to do it just like I did the first op. I'm going to focus on making sure that the program is running correctly. I need a vice handle. Where's it at? I'm going to focus on the program and be sure that everything is good. Get a first part proven. And then when I know we got a good part, I'll bring you guys back and we'll show how it looks running through the entire cycle. This was my first test block and everything went well with the exception of one cutter, and that was my 1/16 diameter 4-flute end mill. It snapped off on the second pass as soon as it started engaging. So maybe I'm pushing this one a little too hard. So I am modifying the program to take a total of 6 step downs. It's 60 thousandths deep. So I'll go down 10 thousandths a pass and see if it'll last through that. I've got one more of these guys. I'm going to load it up. I'm going to run just that tool path there and see if that will get that cut out. If I can get that one to work, then everything else worked out great. And then we can get you some really good close-up video of all the machining action. So I'm going to keep working on this and see if we can improve on that tool path there. We have a successful part this time, so my modifications to our little 80 thousandths wide groove, it worked out good. So this one's ready to come out, put another piece in, and then I'll get you guys some better video. I'm gonna go ahead and unlock the vise now. And by the way, I did run coolant on that tool path there, so I'm gonna do that. The only thing left to do is deburr the bottom of these holes. So I'll just do that by hand out of the machine, but man, look at that. That is awesome. It looks good. So far, everything worked out great, except for that one end mill there, but I think we've got that fixed. All right, let's go ahead and cut another one. All right, that finishes the facing up. Now we're going to grab the 3/8 end mill. Go back to some adaptive. Now we're on to the flat toolpath. Just going to clean everything up. All right, 3/8 mills finished. Now we're going to grab that 1/16, and I am going to run coolant on this. I'm going to have to adjust that once we get it down there. All right, I'm going to stop it there. Let me make an adjustment on my coolant. That's what I was trying to avoid. Maybe we can touch it right there. All right, here we go. So it's supposed to be taking 10 thousandths of pass on the depth. The air's in the coolant, so it's going to spit at us. All right, that was a successful tool path there. I'm happy with it. We didn't break it. Now we're going in with our 1/4 inch ball mill. And we're surfacing those 4 angles. I've got that set at a 5,000 step over per pass. Okay, a 3D surface is finished. Now we're going to grab our 1/4 inch spot drill. Just getting you guys focused. All right, and then we're going to spot it and chamfer it all in one cut here. All right. So next up is our 3.3 millimeter drill. Now for the drilling and tapping, I'm gonna use some of our CRC cutting oil here. That cutting oil does a good job, helps lubricate the cut, and it's not making a huge mess up there for our video. All right, drilled holes, drilled and chamfered. And once again, I'm going to slow that down. Run some of our foaming cutting oil here and send it. You see that cutting oil clinging to the cutter. And done. Okay, so we're on to our last tool path now. I'm gonna clean this off. Our deburr, one of my personal favorites. Let me move this nozzle up. So we're running a 1/8 diameter 4-flute ball mill, and I've got it set for an 8/1000 edge width. That's a really great tool path. It is an add-on for Fusion, but if you can swing it, I would highly recommend investing in it, because it's gonna, it just adds to the finishing of your parts. That is it. That is the end of the program. I didn't set my my home coordinates here, so we're going to jog it up, bring it to us. Spray some of our chlor-free degreaser on here, and it'll blow that cutting oil and stuff right on off there. Everything feels good. Man, it looks good. Let's get it out of there. So we do have to deburr the 3 holes. That's easy enough to do off on the bench over there. I'm happy with it. We got a great looking part. So we now have 2 successful parts that we have machined. These are good parts on size that are going to supply the customer with the part that they wanted. But I've got one more piece here that I want to machine, and I decided to make a change in this one with the hopes that this one is going to turn out slightly better than the first 2. And if it does, this will be the one that I actually give to the customer. And the change that I made is, instead of the original facing that I do on Op 2, you can see the tool marks where on the top of these 2 ribs here where we face back and forth. I would actually like the finish on all 4 of these upper ribs to have the same pattern where we come across the top in one simple cut. So what I have done is I have modified my program, and we're going to be using, so this is the piece, we're going to use an adaptive clearing, a 2D adaptive clearing, where we're going to come around and just face this hat off. It's going to leave 10/1000ths on the top of that, so that whenever that tool path comes in to cut the top of these ribs, I now have all 4 of these to be touched off, and it'll make 4 passes and cut all 4 of those so that the finish will be uniform on all 4 of those on the top. That's the only change that I've made, and I'm ready to get it done. So we'll go back to the mill and we'll get this last piece cut. All right, that's where our changes was made to the facing op. And I forgot to adjust the RPM on that last adjustment that I made, but that's okay. Move on to the 1/16 in mill. I have to adjust my coolant before we start our cut, by the way. All right, that finishes up the third piece there, and it looks like it worked out well. We got a nice uniform cut pattern across the top of those 4 ribs, and everything else maintained just like we had. Only thing left to do is to use our Noga tool and just deburr those 3 holes on the bottom. Other than that, this is done. It looks good. I'm happy with it. All right, this is the one that we just cut. I'm going to just take this little Noga tool with a narrow tip on it. A few licks with the Noga tool does the trick. That looks good. I'll do these guys too. This one I've already done that one. There we go. We are just about finished up. I went ahead and took the set screws out. We'll go ahead and put them in the piece that we're going to give the customer, which is going to be this guy. This is the one that we just machined, the 3rd out of 3 parts. Set screws are going all the way through. Good to go there. All right, so there's our finished part, and there is our sample. I've done some measuring across everything using just calipers. Everything is measuring exactly how I designed it in Fusion, and I'm real happy with it. Keep in mind this is a cast part. You have a little bit of draft on there. Nothing is perfectly square, so I did the best I could to get general dimensions off of everything, like an average dimension, and that average dimension is what I ended up making all of these components here, all the features, should I say, of our part. Well, I think we have come to the conclusion of this video project, and I am really happy with the outcome of our part right here. I wanted to repeat what this was for because I said it in the beginning of the video, but I can't remember what it is. That's why I have it written down here. It's an adjustable base bridge saddle block for a 1990 Ibanez Sabre base. And I apologize if I say that wrong because it's a brand I've never heard before. And I can't remember how you pronounce that. But we have a great looking part here. I think it's very, very, very close to what this original casted piece is. I did my best on measuring it and trying to get all of our dimensions as close to this part as we can. And I hope that we get good news whenever they get a hold of this and they get it back on that guitar. I am going to tell them to let me know. I'd like to know, even if it just works out perfect, I'd still like to know how this performs and how it works for them. So my hopes is that it's going to work great. But the beauty of the way that I designed and machined this using our Milltronics tool room mill there is that now this is an easily repeatable part. If they decide that they want this made again, maybe out of a different piece of material, it's going to be no problem to do that. No fuss. I don't have to concern myself with how much time I spent making just one on a manual mill, because now I can set up 2 work offsets in the event that they want this done, set up the 2 vices in there, set up which would be 9 tools now instead of the 10 tools. The program's already in there, and you just put another piece of stock in, hit cycle start, and go to town. Easy repeatability. That's one of the beauties of using CNC equipment. But this is a project that I knew that I wanted to go that route whenever he handed it to me, and I knew this would be a good part to model up in Fusion and to see it cut over there on the Milltronics. So I'm really happy with it, and I hope it works out good for him too. So anyway, that's going to wrap this up. I hope you enjoyed the video. I enjoyed sharing it with you, and I hope you come back for the next project. We'll see you then.
I mean, there is a resonance and sustain in the body that definitely was not there before. All right, so you hear how I got that, but then when I go here, it cleans up. So that means that this fret right here is higher than that fret. So I'll have to do some fret work on this fret, because when I fret that fret, this fret is out of the equation and out of it. It's clear, it's ringing clear. So I got a high fret right here in front of that note. That's not a problem. Everything else is looking good. High fret right here, not a problem. Yeah, so the bridge works great. Absolutely. Functions exactly how I want it. Cascades down in the measurements I need it to. Everything else that's going on with the instrument is it's just handwork from here on out.
That's good news. I'm glad to hear it.
Yeah, I got minor fret work to do on my end right here, and then put the electronics in, and this bass is going to be considered done.
Awesome. So that's going to work for you.
This is going to work for me. This is great. Customer's going to be very happy. Thank you, Adam.
You're welcome.
Yeah.